This Introduction to Python series is part of the EPSCoR Track 2 DDMD workshop. This presentation introduces the concept of branching. There will be times in our Python programs where we want to execute a block of code under certain conditions. This is made possible through conditional branching. Conditional branching consists of a test, which is an expression that evaluates to true or false. Then you have a block of code that is executed if the test evaluates to true, and optionally you can have a block of code that's executed if the expression evaluates to false. In Python, conditional branching is implemented using an if statement. An if statement is a branching construct whereby a set of code is executed based on the truth value of a condition. So the syntax of an if statement is the reserved word if, then a condition, and that condition evaluates to true. All of the code indented under the if statement is executed. So again, if the Boolean expression is true, then the computer executes the instructions within the body of the if statement. Otherwise, we skip all of the code. And how do we define the body of an if statement? Similarly to our iterative loops, we end the if statement header with a colon, and then we indent everything that's under the control of that condition. Here's a simple example of an if statement. So in this code, we ask the question, if x is greater than y. So if that's true, if the value stored in the variable x is greater than the value stored in the variable y, then we're going to print the value stored in x is greater than the value stored in y. If x is not greater than y, that print statement does not get executed. Here we present another example of an if statement. In this example, we ask the user to enter their grade point average. We convert that input into a float and we store it in the variable GPA. Then we ask the question, if GPA is greater than 2.0, we print your application is accepted. Following that body, we have the print statement, thank you for your application. So the first print statement is associated with the if statement, is only executed if the condition is true. The second print statement is always executed because it is not indented within the if statement. This example just serves as a reminder that the code block under the if condition can contain multiple Python statements. So in this example, you see that we have two print statements under the if condition. The if statement has an optional else segment, and the statements that are indented under the else are executed if the condition evaluates to false. So in this example, we have x equal to 5 and y equal to 10. If x equals y, the computer evaluates that evaluates to false. So the statement indented under the else is executed, and x or 5 is not equal to 10 is printed on the screen. Following that, the print statement not part of the block is executed. Yet another option is the if-else-if statement, and this construct allows us to add an additional condition. So let's consider how the computer would execute the following example. So x would be assigned the value 5, y would be assigned the value 10. Then the condition x equal to y would be evaluated. And if x is equal to y, and in this case that's false, so control of the program would go down to the else if statement. Next, the computer would evaluate the condition x less than y. Well, x is less than y because 5 is less than 10. So the body of the state of the body of the else if is executed, and the body is identified by those statements indented under the else if. So the computer would print 5 is less than y, and then x would be assigned the value 5 minus y, or minus 5. Lastly, the final print statement would be executed, and this statement is executed in all cases, and the computer would print final values of x and y are minus 5 and 10. So let's examine the previous example, but assign x the value 15 and assign y the value 10. We evaluate the condition x is equal to y. That evaluates to false. Control of the program goes down to the else if statement. We evaluate the condition x less than y. That's false. So the control of the program goes to the final print statement under the else if construct, and the print statement final values of x and y are 15 and 10. Note that neither block under the if or the else if is executed because both of those conditions evaluate to false. We're going to look at the example one more time. This time we're going to assign x the value 10 and y the value 10. The computer evaluates the condition x equals y, and that's true. So the block under that if statement is executed, and we print 10 is equal to y, and we assign x the value of 10 plus 10, or 20. Then control of the program goes to the final print statement, and the final values of x and y are 20 and 10 is printed on the screen. Let's write a Python program that'll identify the highest grade out of a group of class grades. So we're going to write this program that asks the user for class grades, and then we'll print the highest grade. Note, we'll use a -1 as a sentinel to indicate that all the grades have been entered. Whenever we're designing a program, we always want to identify what is the input, how is the input going to be processed, and what is the output. In this example, our input will be a set of class grades. The process will be, for each grade, determine if it's the highest grade, and the output will be the highest grade. Now we're going to write our algorithm for finding the highest grade. And basically what we're going to do is we're going to continue asking the user for grades until they enter a -1. Once they enter a -1, we're going to print out the highest grade. So specifically, we're going to ask the user for a grade. Then we're going to set the highest grade to that first grade. Then while the user's grade is greater than a -1, we're going to look at that grade. And if that grade is greater than the highest, then that becomes our highest grade. Then we're going to ask the user for another grade. We'll continue in that while loop until the user enters a -1. Lastly, we're going to output what we determined is the highest grade. Here is a Python program that determines the highest grade out of a group of grades entered by the user. The first statement in this program asks the user to enter a grade. It converts it to an int, and that grade is assigned to the memory location grade. And in our example, the user enters an 82. Next, we're going to assign grade to the memory location highest grade. So initially, highest grade is the first grade entered by the user. Now we reach the while statement and the computer evaluates the expression grade greater than 0. Well, the value stored in grade is 82, and that is greater than 0, so the body of the while loop is executed. The first statement within the body of the while loop is the if statement. So now the computer evaluates the expression grade greater than highest grade. Well, the value stored in grade is 82. The value stored in highest grade is 82. Grade is not greater than greatest grade. So the control of the program goes to the next statement, not part of the body of the if statement, which is asking the user to enter another grade. And in our example, the user enters 70. Control of the program goes back up to the top of the while loop, and the expression grade greater than 0 is evaluated. Well, 70 is greater than 0, so the body of the while loop is again executed. Now we execute the if statement, and the condition grade greater than highest grade is evaluated. Well, the value stored in grade is 70. The value stored in highest grade is 82. 70 is not greater than 82. That it evaluates to false, so the body of the if statement is not executed. Control of the program goes to the statement, not part of the body of the if. And again, we ask the user to enter another grade, and in our example, the user enters a 90. Again, control of the program goes back up to the top of the while loop. The value stored in grade is 90. It is greater than 0. The body of the while loop is executed, so we execute the if statement. If grade is greater than highest grade, the value in grade is 90. The value in highest grade is 82. 90 is greater than 82. So we execute the body of the if statement, and highest grade is assigned the value grade. Now we execute the statement under the if statement, which is asking the user for another grade. And in our example, the user enters a 65. Control of the program goes back up to the top of the while loop. 65 is greater than 0. We execute the body of the while loop. Grade greater than highest is false because 65 is not greater than 90. We go to the statement under the if statement, ask the user for another grade, and the user enters the grade -1. Control of the program goes back up to the top of the while loop. The value stored in grade is -1. Grade is not greater than 0. That condition evaluates to false. That gets us out of the body of the while loop, and we go down to execute the final print statement. 90 is stored in the memory location highest grade. Therefore, the highest grade is 90 is displayed to the user. Let's write another Python program that asks the user to guess a secret number. The program will count the number of tries it takes for the user to guess that number. The algorithm for our guessing game program will begin by assigning a secret number. We'll do this by generating a random number between 1 and 20. Then we'll ask the user to guess a number, and we'll initialize our count to 1. Then, while the user's guess is incorrect, in other words, while the user's guess is not equal to the secret number, we'll increment our count and we'll get another guess from the user. And we'll continue that until the user's guess equals a secret number. And then lastly, we'll output the number of tries it took to guess the number. Here is one solution to our guessing game problem. We begin by importing the random module. Then we leverage the randint function, which is part of this random module, to generate a random number between 1 and 20. We assign that value to the memory location secret number. Next, we ask the user to enter a value between 1 and 20, and we assign that value to user guessed. Then we count that as one guess, so we assign 1 to number guesses. The next thing we do is begin the top of our while loop. So we check to see if the user's guess is equal to the secret number. It's possible that the user guessed it on the first try. If it's false, we execute the body of the while loop. So we assume that the user's guess did not match the secret number. So we increment our count and we ask the user to guess again. And we continue this loop until finally the user's guess matches or is equal to the secret number. In other words, user guess is not equal to secret guess is false. Lastly, we execute the print statement and we tell the user how many tries it took for them to guess the secret number. Let's refine our guessing game program. Let's add some functionality so that if the user's guess is incorrect, the program should provide a hint telling the user if the guess is too high or too low. So our original algorithm will be modified so that if the user's guess is incorrect, within the while loop, we'll add a statement so that the system will output whether the guess was too high or too low. In this version of our guessing game program, we add an if statement within the body of our while loop. So within this if statement, we look at the user guess and the secret number. And if the user guess is less than the secret number, the program will output your guess is too low. Else, it will print your guess is too high. And this if statement will enable the user to more quickly narrow in on the correct secret number. Let's make one more change to our guessing game program. So in this version, we're going to limit the number of guesses that the user has to guess the secret number. So in our algorithm, we're still going to assign a secret number, but then we're going to assign the limit of tries. We're going to initialize count to 1, and we're going to ask the user to guess a number. So now, while the user's guess is incorrect and the count is less than the number of tries, we're going to have the system give a hint and tell the user whether it's too high or too low. And then we're going to get another guess from the user and we're going to increment count. We're going to stay in that loop until either the user exceeds the number of tries or the user guesses the number. And following the while loop, if the user's guess is equal to the secret number, we'll output congratulations. Otherwise, we'll print sorry and inform them what the secret number was. Here I've highlighted the changes that were made to our previous guessing game solution in order to implement limited tries. So you can see at the top of the code, we have a variable called try limit, and I've assigned it the value 3. In the while loop, I've modified the condition so that either user guess is not equal to secret number, and number guesses is less than or equal to try limit. So as long as both of those are true, the loop continues to be executed. Once one of them becomes false, either user guess is equal to the secret number or number of guesses is greater than try limit, the while loop is terminated and the execution of the program follows the while loop, which is the if statement. So we've added an if statement at the bottom of our code, and we want to check to see which one of those conditions got us out of the while loop. So if user guess is equal to secret number, so the user guessed the number, we say congratulations, you guessed the secret number. Else, print sorry, you did not guess the secret number, and we tell them what the secret number was. Here's a display of one execution of our guessing game program, which implements try limits. One of the things I don't mention very often is notice the line right above the while loop that starts with a pound sign. That's how you can add comment statements throughout your program. So I added a comment statement there just informing somebody that might look at my code that this while loop continues until the secret number is guessed or the user is out of tries. In this particular run of the program, you can see that in 3 guesses, the user guessed the secret number.